Good day, this is the Professor, CBMD PhD, and today's Wednesday, October 18, 2023. It is 1:57 and 9 seconds, a.m. Eastern Standard Time, and today's research, cellulose gels. So let's jump to it here. Mimicking a bird's sticky spit to create cellulose gels. Date October 17, 2023. Source, North Carolina State University. As cellulose is a wonderful material for making hydrogels, which are used in applications ranging from contact lenses to wound care and drug delivery. But creating hydrogels from cellulose is tricky, and often the processes used to create the hydrogels are themselves toxic. Normally, you have to first dissolve the cellulose and then induce it to cross-link or form the structure of interest, which often requires the use of difficult-to-handle, unstable, or toxic solvents. The swift family of birds, small birds who use their saliva to hold twigs in place when building their nest. When birds do this, the saliva acts like a natural resin that holds the nest together and encourages the fibers within the nest to interconnect or cross-link, which is exactly what they want the dissolved cellulose to do when making hydrogels. So they ask themselves, what if they mimic the birds? The researchers added a water-soluble cellulose called carboxymethyl cellulose to an acid solution and dissolved the carboxymethyl cellulose. Then they added powdered cellulose fiber to the solution and subjected it to 4 pounds of freezing and thawing. The result was cellulose gel. Think of it as adding a thickener to water, like you would a pie filling. By changing the pH, the carboxymethyl cellulose, the water essentially becomes sticky. As freezing and thawing the solution causes the cellulose to compact and interweave itself into the sticky network, giving you a more organized structure, just as swifts do when they create their nest, only they don't have to use beaks and saliva to do it. As freezing and drying the gels resulted in cellulose foam, the researchers repeated the process with bamboo fibers as well, which suggests that it could be useful with many other lignin and cellulose-containing fibers. The cellulose gels are robust, stable at room temperature, and can be tuned to degrade on a schedule, so would be useful in drug delivery applications, among others. This opens up a promising new window for using biomimicry to process these insoluble cellulosic materials in a greener way. And this is a professor of space technology, advanced physics, mathematics, computer science, and nature of research. This video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.